So what you see here, of course, we see one image of the Statue of Liberty. We see Boston's skyline. What you may not know is that several thousand years ago, when we were having the Ice Age, these cities, this famous icon, were completely covered with ice, right? The Ice Age, you've heard about the Ice Ages. And on our planet, we've been through several Ice Ages. So what you may also not know or understand is that the Ice Age that caused this, right, Statue of Liberty to completely be under ice and then Boston skyline to be thousands of feet of ice above it, there was actually only a -4 degrees Celsius average temperature change then, and that was what caused the Ice Age. So when we're talking about climate change, we're not talking about such a huge mammoth number or increase in temperature. These small little changes have drastic results. So in this video, I want to talk about all of the impacts of climate change, some evidence to support climate change, and then at the end, we'll talk about some mitigation or ways that maybe we can combat climate change. Let's get started. So you may have heard something along the lines of, well, hasn't the climate always been changing, right? We had ice ages, we had all of these different times on our planet where the climate was different. Well, yes, that is true. The changes then were very slow. Now, however, the changes are very rapid and are actually not due to natural causes. In fact, we know that what is changing our atmosphere is actually the emission of greenhouse gases, mostly CO2 and methane. So if you look at this image, this globe, what it shows you is the change from 1956 to 1976 temperatures as a baseline. So this is the last decade's average change from here, the 50s, 60s. And what you notice is that, well, some places were averaging about a, +1, +2 degree change, as you see here. But if you look up here, right, in the North Pole, we can see some drastic temperature changes. And remember, -4 degrees Celsius the other way is what caused the Ice Age, or was what the temperature was when we had the Ice Age. So when we're going in the opposite direction, it just makes sense that we're going to have some monumental and catastrophic changes on our planet. So why is this a big deal? Well, because what we know is that there are human drivers and natural drivers to this climate change, right? And this chart does a great job of showing the difference. If you look down here, right, this is the change in temperature from the pre-industrial period. Well, notice that temperatures always kind of fluctuated a little bit, right? But once we get here, 60s, 70s, you can see a drastic change in the observed temperature, that black line. Well, what's causing that? Could it be natural drivers, or is there some human drivers? Well, what we know is if we look back at trends, the natural drivers sort of stay here in this shaded area there, the blue. But when you add in the human drivers, what we're doing, notice this huge increase in temperature. It's off the chart now, right? So for years, we kind of stayed like this. In the past 20, 30 years, look what has happened to the temperature of our planet. So what's causing this? I mentioned it's greenhouse gases. So what are greenhouse gases? Let's think about it. Well, what you may know is that the Earth's atmosphere has this thick blanket of gases. And this actually protects the Earth, right? So the sun comes down. Generally, the sun's heat energy comes down. It reflects back. Goes out of the atmosphere. But think about what a greenhouse does, right? All these gases cause the greenhouse effect. So think about this, right? If you have a little greenhouse outside of your house, what's that do? Well, that people have greenhouses so that they can grow plants in colder temperatures. So if I have a little greenhouse, right, I have my plants in there, then it's got this barrier that could be glass or plastic or some sort of film. The sun's rays come in, but they stay inside, right? It's the same thing that happens in a car, right? If you get inside your car on a sunny day, it's going to be much warmer than the temperature outside. That's because the heat gets trapped inside the greenhouse. Well, that's exactly what's happening on our planet. As the sun's rays come down, because we're adding so many gases to our atmosphere, the heat comes back, hits all these gases, and then is reflected back down. So it can't escape out. So it's basically creating a greenhouse on our planet. These are the three major greenhouses that greenhouse gases. There are several more: nitrous oxide, methane, carbon dioxide. CO2, carbon dioxide is one of our primary areas of focus, and I'll go over that a bit more in detail. So these are some physical drivers of climate change. So if you look at these greenhouse gases, notice this. Scientists estimate that carbon dioxide is doing the most contribution to our change in temperature, right? So CO2 alone is almost giving us a degree Celsius of climate change. But notice methane, pretty high contributor. Other gases make up a lot as well. Some gases actually lower and these are aerosols, lower the temperature of the greenhouse gas. But overall, we're putting out so much of this that it overshadows any of those other compounds. So since CO2 is that major contributor, like I mentioned, I want to quickly go over the carbon cycle to remind you how we're getting all this CO2 in the atmosphere. So the carbon cycle, and you probably learned this in biology, basically starts when we take, fossil fuels, coal, oil, natural gas, and we use it, right? We ignite it, we turn it into these gases. It goes into the atmosphere. So now we have all the CO2 in the atmosphere from these power plants, from our electrical grid. Then, of course, we like to drive our cars. There's me and my little convertible. I wish I had one of those. And what you see here is, of course, all of these, we're burning fossil fuels. That's going to go up into the atmosphere as well. Now, has the Earth ever found a way to deal with that? Well, of course, we know that plants take in CO2, right? Through the process of photosynthesis, they take in that CO2, and even some of it's absorbed into ponds, lakes, waters, etc. Then the plants in that water can use it. Now, then, of course, what happens? We and other animals eat that. We undergo cellular respiration. We put that CO2 back into the atmosphere. In fact, we know cows put a lot of methane and CO2 into our atmospheres. So livestock and what we eat often is a major contributor as well. So we've got that. Sometimes CO2 diffuses in and out of water as well. And then, of course, that dissolved CO2 can be taken by the plants, more photosynthesis. But when all that stuff dies, right, and you think about the history of our planet, when all these things become fossils, right, the fish, the plants, the animals, that carbon is trapped in these fossil fuels. Well, what do? We dig up all that fossil fuels, all that carbon which has been trapped, and then we, burn it, put it in our power plants, put it in our cars, and the carbon dioxide goes back into the atmosphere. So the carbon cycle here is really important contributor of climate change. So I want to now go over the evidence for climate change and tell you that it's estimated that the temperature will rise from 1.4 to 5.4 degrees Celsius within the next century. Those numbers are scary, right? Remember, -4 the other direction, ice age. So what's going on? Well, if we measure the CO2 concentration over the past several hundred thousands of years, right, what we'll notice is when the Industrial Revolution started, the CO2 numbers skyrocketed, right? So if you look back here in the Ice Age cycle, CO2 went up and down and up and down and up and down several 100,000 years ago. But then, as we get closer to us, holy cow, look at this number, right? The CO2 concentration in our atmosphere has exploded. And it's interesting to see, if you take these years and sort of stretch it out a bit, you can see the global average temperature also corresponding to that change in CO2 concentration, okay? So right now, right, we're already at 1 to 2 degree temperature change on our climate. If we keep things going the way they are, it's going to be catastrophic. So I want to go over the impacts of climate change in detail. This is a summary of everything I'm going to be talking about in the rest of this video. So what's happening? How do we know what impact is climate change having? Well, one, deserts are expanding. Two, we're going to talk about heat waves and wildfires becoming more common. We're going to talk about the warming Atlantic and all that permafrost and glaciers that are melting. We're going to talk about species becoming extinct and relocated. And then another big issue is our oceans are becoming more acidic. So what I'm going to do is I'm going to hit every one of these and give you a little evidence to show you all of these impacts that we're going to see from climate change. So the first one, deserts are expanding. This is the fancy word, is called desertification, right? This is degrading land. When things turn into deserts, we lose biological productivity. So here's a picture. You may have heard of Lake Mead in the news a lot. This is one of the main sources of water, probably the main source of water for Vegas, areas of Colorado, a lot out there in the West. This was a picture taken of Lake Mead in 1985. Here's one in 2022. Now it's kind of hard because this is such a image from so far away, but you can tell, look at the difference here in the size of this lake, right? The desert is encroaching in this lake because the lake is drying up. So what we see here is a major problem. In fact, in the news recently, Lake Mead is going down so much, right? Vegas is scared they're going to run out of water. But one of the other things that's kind of scary is that as the lake is regressing, they're like finding sunken ships and dead bodies that have been in that lake for a long time. But because the lake's going down so much, we're finding all that stuff, all right? So this is a big problem. Deserts are expanding. Our water is decreasing, our supply of water. It's not just happening in the U.S., it's happening around the world. Lake Chad in Africa, if you look in 1973, all this sort of blue was the lake and water. But notice it's changing over time, and these different colors are showing not water, but showing land. And so this is how small from here to here that lake has shrunk over the course of 50 years. Now, if you look at the U.S. Department of Agriculture, they have posted where we think desertification vulnerability really lies. In other words, they're projecting that in these red and orange areas, we're going to likely see more desert increase. Now, what about the gray? Well, the gray, it's already dry and already a desert, right? But you can see we're moving up away from this sort of equatorial line here. So we're going to be seeing more and more deserts on our planet as climate change continues to happen. So heat waves, wildfires are increasing. We're seeing the frequency and severity of droughts really already increasing. I was in Europe a few summers ago, and they were talking about this record heat wave and drought they were having. Of course, it happened to be when I was there. But this is becoming more and more common. It seems like every year, right? Record heat. We've never seen this kind of heat wave before. And if you look at this graph here, what we're showing you is that we're having more frequent extreme weather as a result of this climate change. So you may have heard the word like, oh, this is a 50-year heat wave, a heat wave that happens once every 50 years. Or this is a 10-year drought, a drought that happens once every 10 years. What we're seeing over time, as global warming is going to happen, we're going to see more and more of these 50-year heat waves, these 10-year heat waves, continue to occur as we get hotter and hotter. So it won't be a 50-year heat wave anymore. It'll be like a 2 or 3 year heat wave that we're going to start having. And then You probably have also seen so much about the wildfires, especially out Colorado, California, and you may remember even in Australia. The acres burned by wildfires in the United States has drastically increased from the 80s, right? So we went from 1 million acres on average to 10. That's a times 10-fold increase just in 40 years for these wildfires that are getting out of control and just damaging so much. Okay, so another major issue, of course, is the warming Atlantic. And this is causing deglaciation, which is a fancy word for the glaciers are melting, right? So glaciers naturally melt at the end of an ice age, but the greenhouse gases, this warming climate, is really accelerating this glacier melt. So here we have a picture of a glacier in Washington State in 1973. You can see all the glacier there. An image taken in 2006. Well, where's all the ice? Yeah, it's melted, right? So these glaciers are melting at an alarming rate. Permafrost, something else that you may have heard of. If you think of areas of our planet that's always cold, right? It's always freezing up there. Well, their ground is actually something called permafrost. So that's just when the ground for 2 or more years remains at or below freezing. And that's actually a really good carbon sink. And I've used that word already once. But a carbon sink is just something on our planet that is storing a lot of carbon, right? And places up north where the permafrost, that's actually storing a lot of our carbon in the ground because it's frozen. Now, as that permafrost starts to melt and form ponds like you see there, or melt and run away, all that carbon which has been frozen is now going to start being released. Some scientists are also concerned that permafrost contains viruses and bacteria and things that humans aren't used to because it's always been frozen. And if that starts being released, we're going to have a lot more problems there too. So along with this sort of melting glacier, I want to talk about melting ice sheets. So you're probably familiar with Antarctica, right, down there at the South Pole. Antarctica covered with ice. In fact, it's the largest mass on Earth, ice mass on Earth, I should say, and it covers 98% of Antarctica. Well, according to this graph, what we can see is the Antarctica ice mass is going down. We have already lost 2,500 gigatons of ice from the Antarctic ice sheet, and that's just going to continue happening. Now, here's what's scary. If all the ice melted from the Antarctic ice sheet, the global sea level would rise 190 feet from where it is. Okay? Scary. The Greenland ice sheet is the second largest ice sheet, right, from Greenland, a little closer to us than Antarctica. And notice we're seeing the same trend happen on the Greenland ice sheet that you see there. Well, why is this a big deal? Well, if that one melted, we're going to have a sea level rise of 24 feet. So you take these two together, what is that, 214 feet? If just these two ice sheets, we're not talking about any of the other glaciers, any of the other ice sheets, we're talking about just these two. If just these two ice sheets melted, 200 feet is going to come up to the arm of the Statue of Liberty. So think about all of our major cities. Where are they? Most of them are located on coasts, right? Because shipping, close to the water. Many of the world's major cities will be completely covered with water if these ice sheets continue to melt, right? A scary thought. Another really interesting thing as it relates to biology is that species are becoming extinct and having to relocate because of climate change. This right here is the Bramble Cay Melamies, and this actually was the first species we think went extinct because of climate change, and that happened in 2015, right? So we've already lost species because of climate change. And of course, bumblebees, you hear a lot about bumblebees. We know this century the bumblebee population in North America has dropped roughly 46%. That's scary because so much of our food, of course, is pollinated by these bees. So when we're having a drastic reduction because of climate change in this bee population, it's going to affect our food supply. And then everyone cares about the polar bears, right? Some scientists estimate that our polar bears could go extinct because of their habitat loss by 2100. Okay, so a lot of these species on our Earth already are going extinct, are relocating, or may go extinct in the near future. Oceanic acidification is really the last main climate issue that I want to talk about. There are many more. I'm just bringing up sort of the big ones here. What's happening? Well, oceanic acidification. If you break the word down, right, our oceans are becoming more acidic. Well, as you know, if you've taken biology or watched some of my other podcasts, organisms function best, their enzymes, at certain pHs, right? So if the oceans are becoming more acidic, that's going to affect a lot of the life in the ocean, right? If you think of animals with shells and they have all this calcium, that acidification is going to affect or impact a lot of sea life. So what's happening? Well, we have all the CO2 in the atmosphere, right? A lot of it gets dissolved into water, right? And then this forms a bicarbonate, and then it releases these hydrogen ions, right? These charged ions. And if you took a chemistry class, you know this is what makes things acidic. And so, as you can see, the current pH is really, over time, changing, going down, becoming more acidic. And this causes lots of issues. One of them is coral bleaching. So that beautiful coral that we have in our oceans, right? These animals, coral is an animal, are becoming sick, right? And they're losing their color. This acidification is causing this bleaching. So if you ever, if you want to see the beautiful coral, especially in the Great Barrier Reef, you need to go now and see it. All right. So this video I know has been a little doom and gloom, and that's because this is a serious issue. But there are things we can do to fight, to help to preserve our planet. So these are what we call climate change mitigation. How are we going to mitigate this damage done? Well, one easy way, right? If so much of our climate change is the CO2 from these power plants and our use of energy, well, one thing we need to do is conserve energy, right? We can buy appliances that are high efficiency. We can move to things like LED light bulbs in our house. They use so much less energy, right? So we need to be better at conserving energy. Although that's hard, right? Everything we're doing on our planet seems to be, we need more energy. We need energy for everything. So if we're needing more energy, one thing we need to do is get better energy, so-called clean energy, right? Now, nothing's ever 100% clean, but maybe let's call it cleaner energy, right? Using the wind, using solar, even nuclear, right? Nuclear energy is expensive, but it has to be, in my opinion, considered as we try to fight climate change. So conserving energy, using more clean energy. Also, sustainable agriculture. People don't think about this a lot as contributing to climate change sometimes. But if you think, right, our food is grown on one part of the world. It has to be shipped, right? Planes, boats, cars to our grocery stores. And then we get in our grocery stores, we get in our cars, and we go home. One way to help with all of this energy is sustainable agriculture. Grow your own food, right? I have lots of gardens. They don't always go great for me, but it's one way to reduce the impact of climate change. Or go to your local farmer's market like you see here. Get food, agriculture that's been grown locally. It doesn't have to travel as far. Another thing that some farmers are doing is having more sustainable agriculture through their practices. This is some coffee growing in some what they call shade-grown coffee. They're using the natural environment, the trees and the shade, to help grow this coffee. So there's some smart, innovative things that we can do to be more sustainable with our agriculture. And then, of course, one of the most important things we can be doing is trying to sequester or reduce the carbon that's in our atmosphere, right? If there's too much carbon, let's take it out. Well, the most natural way, of course, is to plant things, right? Trees take in a ton of carbon and store it in these carbon sinks. So planting trees, limiting our deforestation is going to really help with carbon removal, but also sequestering carbon. There are lots of really smart scientists right now trying to think of ways to take carbon out of the atmosphere, maybe using a machine or maybe using some chemicals, and sequestering it so it's out of our atmosphere and it's formed into some sort of solid compound. Okay, so as doom and gloom as this video may have been, and maybe as scary as it seems at times, there are smart people working on these things. We just have to support them, and we just have to do what we can to help our climate. We only have one planet, and until we have a lot more technology to move to other planets, we're going to have to take really good care of this one. Hopefully this video helped you understand some of the arguments for climate change and what's happening on our planet.